Okay, in this video we're doing Calc BC Problem Set number 32. The problems in a playlist are in the description below. Let's take a look. Number 1, the function f of x has tangent line y equals negative 2x plus 9 at x equals 3. The derivatives at x equals 3 shown and derivatives at x equals 3 shown in the table above. Write the third degree Taylor polynomial to f of x centered at x equals 3. So we need to know the value of the function, the first derivative, second derivative, third derivative. If you look, we have second and third in the table. We're going to use this tangent line to find the value of the function and the value of the first derivative. So it's always important to remember that that's something you can do. So I'm going to start off, I'm just going to find f of 3. Now it's also true that the tangent line is the first degree Taylor polynomial, so I guess you could kind of just slot that in there for the first and second terms. I don't really recommend it, but you could do it. Instead I'm going to actually find the values. I want this to, I want the form of it to look the way that it should look. I don't want to just have a negative 2x plus 9 to lead off this thing. That'd be weird. All right, the derivative, so f prime of 3. We're just going to find the derivative with respect to x of the tangent line, which is obviously negative 2. And now we're just in that position where we're going to write this thing that we've memorized, and these cause us no stress whatsoever. It's the value of the function plus first derivative x minus 3 to the first over 1 factorial. So that's going to be negative 2 x minus 3 to the first over 1 factorial plus second derivative x minus 3 to the second over 2 factorial. So that's going to be 8 times the quantity x minus 3 squared over 2 factorial. And then plus third derivative x minus 3 to the third over 3 factorial. Third derivative from the table, negative 12. So we're going to have negative 12 quantity x minus 3 cubed over 3 factorial. I'd leave it there if there was nothing else to do. So I'm going to box that, move on to the next part, and you'll see that we actually kind of need our previous answer to do this, and so I am going to end up simplifying it. But in general, you don't want to simplify those things. We need to write the fourth degree Taylor polynomial for g of x, which is the integral from 3 to x of f of t dt, centered at x equals 3. So we know f of x. I'm just going to import our answer. I'm going to simplify this. So I'm going to take care of the factorials and simplify anything that does. I think it simplifies down to this. So we had negative 2 over 1, we had 8 over 2, and we had negative 12 over 6. So that's where those coefficients have come from. Now g of x is the integral from 3 to x of that thing, but dt, or d, you need a dummy variable. So t and u are pretty much the most common. So I've changed all the x's into t's from f of x. So I'm integrating f of t from 3 to x. That's a definite integral. So there's not going to be a plus c at the end. So when you integrate 3, you get 3t, and then you plug in x, you plug in 3, you get 3 times the quantity x minus 3. So the first term of this thing, as we integrate it, is actually just going to be 3 times the quantity x minus 3. All of the other ones, you're just doing plus 1 times the reciprocal. It's kind of the beauty of power series, is that you just use the power rule. You reverse the power rule to integrate them. So plus 1 times the reciprocal gives us negative 2 over 2. And then the quantity, it's t minus 3 squared. And then you're going from 3 to x. So you plug in x, you plug in 3. You're just left with x minus 3 squared. I'm going to take care of the rest of them. You pretty much do these in your head after you've done enough of them. You don't pretty much. You definitely do them in your head. And then our final term here. So we get negative 2 over 4. Obviously, you can simplify that, but there's no reason to. All right, so that's our answer for part B. Integrating and taking derivatives, really common when you've written a polynomial already. Let's take a look at number 2. This is a calculator question. The velocity vector of a particle moving the xy plane is given by cosine of square root of t plus 1 comma sine of t squared. The particle is at 4 negative 1 at t equals 2. All right, part A, write the equation of the tangent to the path at t equals 2. You can do this on a calculator, and every time I write this problem, I put in the calculator questions, and then I just do it by hand. We need to find dy dx, and in this case, you can just do that because we already have the velocity vector. It's easy to do. So dy dx is going to be dy dt divided by dx dt. And then we need to evaluate that at t equals 2. So the best notation is just a giant such that t equals 2. And then if you just plug in 2, you can do it, it's not that hard to do in your head, I think. So when you plug in 2, you're going to get sine of 2 squared, so sine of 4. And then when you plug in 2 to dx dt, you're going to get cosine of the square root of 2 plus 1, which doesn't really simplify, so you just leave it. It's messy. It's fine. And then our tangent line, just make sure that you use the ordered pair for negative 1. t equals 2 no longer really comes into this thing. I mean, it is the tangent line when t equals 2, but it doesn't matter. Our tangent line is going to look like y plus 1 equals sine of 4 over cosine of root 2 plus 1, the slope, quantity x minus 4. Number one mistake that I see people make, they use the t value instead of the x value. It's a weird mistake, but it's very common. All right, let's take a look at the next part. Find the particle's position at t equals 3. This is a classic of the genre. So we're going to use fundamental theorem, rearranged. So we're going to go with what we start at plus displacement. So x of 3 is going to be what we start at, x of 2 plus the displacement from 2 to 3, which is the integral from 2 to 3 of x prime of t dt. For y, it's the exact same thing. Y of 3 is y of 2 plus the integral from 2 to 3 of y prime of t dt. I'm going to put up just a screenshot of what I did on the calculator because I've done this so many times now. And then our values are 3.158 and negative 1.031. And I like to write a little sentence just summarizing. So position at t equals 3 is that. All right, let's take a look at the next one, part C here. Find the distance traveled by the particle from t equals 0 to the first time that the particle's position has y coordinate negative 1.3. To clarify, that's the first time y equals negative 1.3, because I wasn't sure if that was very clear. So this one's a little more complicated, so I'm actually going to do it on the calculator and edit it in here so that we can watch it. So I will start off, though, by saying that y of t, so a function, is going to be what we start at, which is negative 1, plus the integral from 2 to t of y prime of a dummy variable, so I just use u du. Let's go to the calculator, do this whole thing, then I'll come back and handwrite in the solutions. Okay, I'm going to take this basically from the beginning. I'm going to define some function. So dx of t is cosine of the square root of t, and then plus 1. Just make sure you're not inside the square root when you do that plus 1 part. And then dy of t is going to be sine of t squared. I'm also going to define a function for y of t. So y of t is going to be negative 1 plus, we're going to do an integral, so that's going to be shift plus, we need to go from 2 to t of dy, the function that we just defined, we need a dummy variable, so I'm going to use u, dy of u du. All right, so you definitely don't want to try to use solve on this thing to get where y is equal to negative 1.3 for the first time. So what I'm going to do instead is I'm going to insert a graph page. So that's going to be doc 4 and then option 4. I'm going to graph y as a function of x because in function mode you have to use x as your variable. I should probably change my window, but I don't even know what to change it to. Definitely like 0 to something, but I'm just going to hit enter. And you can see it takes a while. On the handheld, it'll take even longer, which is why you should really change a window first. So I'm going to also graph now negative 1.3, right? This is the graph of the y coordinates over time. I need to figure out the first time that the y coordinate is negative 1.3. So I'm going to hit tab, negative 1.3, hit graph. Now I'm going to use zoom box so I can see the first time. Let's go menu 4 and then option 2. Then you just click corner. So I'm going to click top left and drag to the bottom right. This is the first time that we hit negative 1.3. I'm going to try to find the intersection. Menu 8, 1, 4. Sometimes the calculator struggles with this because I had defined an accumulation. Not this time. Occasionally that will happen though. I'm going to store this. So press escape, arrow over it, control menu. I can't show it on the emulator, but that's where we would do this. Control is the blue key and then menu is the menu key. Option 5 for store. I'm going to store this as, I don't know, A, I guess. Okay, so that's the first time that the y coordinate is negative 1.3. Now what I need to do is go back here, and I want to find the distance traveled, which is the norm of the velocity vector, the integral of the norm of the velocity vector, on 0 to that time value that I just found. I don't know what that value was. There we go. All right, so let's do that. So we're going to go shift plus 0 to the value we found, a. And then we want the norm of the velocity vector. So I'm going to actually do that. You could also just type it in. Menu 7, 7, enter. Velocity vector. So we're going to do control and then open parentheses, dx of t, comma, dy of t. And then tab out of there. And dt, press enter. We get this. this should be the distance traveled on that time interval. I'm going to go back to the handwriting stuff. I'll see you there. Okay, so we basically started off by saying we needed y of t to equal negative 1.3. After graphing it, we found that t is approximately 1.20872, stored that as a. Then the question is, what is the distance traveled? So distance traveled, we know, is going to be the integral of speed, the integral of the magnitude of velocity, or the integral, in this case from 0 to a, of the square root of x prime squared plus y prime squared. Any way you want to remember that, you just have to remember it. We did all that, and the calculator told us that's approximately 0.620. All right, let's take a look at the next part. So we want to evaluate the integral of x plus 11 over x squared minus 2x minus 8. So initially, when I see something like this, I think u substitution and then reverse power rule, but you would get 2x minus 2 as du, and you don't have 2x minus 2 up top. You have that plus 11, which is a little annoying to deal with. So I'm thinking it's not going to be that. I'm going to try, in my mind, I'm like, all right, well, maybe I'll complete the square, because this is like the weird order that I go in, despite what I may have put up on the screen for you to see as a kind of progression. Completing the square isn't going to help me here either, because I'm going to end up with like a minus value. And ideally, when I'm completing the square, I'm trying to get arctan. So instead, I'm just going to factor this. So this thing factors into x minus 4, x plus 2. So we can do partial fractions. So a over x minus 4 plus b over x plus 2 is x plus 11 over x minus 4, x plus 2. If we let x equal 4, we will figure out a. So that's going to be 15 over 6, which gives us just 5 halves. If we let x equal negative 2, we'll be finding b. That's going to be 9 over negative 6. So 9 over negative 6 is negative 3 halves. So our integral becomes the integral of 5 halves over x minus 4 minus 3 halves over x plus 2 dx. These are both straightforward natural logs. So 5 halves, natural log absolute value of x minus 4. Never forget the absolute value. It'd be hard to believe that anyone is forgetting that at this stage, but who knows. And then plus c, that's our answer. All right, we got one more question here. It's going to be quick though, because it is the logistic differential equation again. And it's written again in a way that's designed to not trick you exactly, but like it's not the way we want it. We want it to be k times y times the quantity 1 minus y over L. We don't have that. We don't have the 1. That 1 is key. The 1 is key for a lot of things, right? Like arctan, geometric series, logistic differential equation, so many things. So what I'm going to do first is factor 12 out of everything in parentheses. So 12 over 24, and then we'll have, the y that's there, obviously, and the quantity. Now we've factored 12 out, so we're going to have 12 over 12 is 1, and then negative 2y divided by 12 is negative y over 6. So we'll have 1 minus y over 6. Okay, so now we can answer the questions. When we're looking for the limit as x approaches infinity of y of x, once it's written the way we like it, the thing that's underneath this y is our limit. So that's just going to be 6. So that's our first answer. Let's look at the next part. We want to find y when y is increasing most rapidly. That's going to be at half of the limit. So since the limit is 6, y is going to be increasing most rapidly when y is equal to 3. That's all there is to this. There's not a lot. Find the range of y of x if y of 0 is 1/5. So we're starting below the limit, and we're just going to go up to the limit. So I'm going to say, since the limit is 6, the range is 1/5, including 1/5, to 6, not including 6, because you can never get there. And then I'm going to say when y of 0 is 1/5. And then there's another question. What is the range if y of 0 is 12? If you remember, I think I got this wrong in maybe the last problem set. So this is a redemption arc. Since the limit is 6, the range is going to be, so you can never get to 6, but you can approach 6. You definitely start at 12. So we're going to say our range is 6 is less than y is less than or equal to 12, and that's when y of 0 equals 12. So you always have to know your relationship to the limit to be able to really say what the range is. But anyway, that's the entire problem set. I hope this was helpful, and good luck.